Okay, welcome everybody to our weekly weather watch. We're going to get started. Today the order is a little bit different, and it's a welcome difference. We're going to have the director of the State Climatology Office, Dr. Steve Vavris, give us an overview of what went on over the summer, I think is what we're going to hear about, and both regionally and maybe beyond that. And this is going to be maybe the first of several periodic visits by the State Climatology's Office to inform us about what's going on climatologically, both regionally and wider than that. So we're really happy about it. I'm kind of, Steve, I'm sorry we didn't think about doing this years ago, but I'm glad we're starting now. There's no reason to say anything except welcome, and we're really looking forward to what you have to tell us. And I'll give you this, because this is part of the recording situation.
All right, how's the audio? Is that coming through? Okay, well, first of all, happy Cloud Appreciation Day, everybody. Really? I'm serious. It's really true. I've been working on that. Okay, turning to climate. So thank you so much for the opportunity for the SCO to give these periodic climate briefings during the year. Most of you, many of you do not know what our office is, what we're about. So in a nutshell, we are about climate services. Just like the NWS is about weather services, we are about climate services, and those are under the 3 I's. So information, so both general information about weather and climate, but steering people toward reliable information. Interpretation, so even if you get the right information, we serve as a translator, communicator, and then finally investigation or research, basic and applied. And importantly, we are part of UW-Madison's Rural Partnerships Institute, and we are also part of AOS. As of last year, we're part of AOS, Extension, and the Nelson Institute Center for Climatic Research. Next slide. We're located just 5 floors above us here, right off the elevator in 1353, and we pride ourselves on having a fully stocked coffee bar, right? So please drop by, get a cup of coffee, and here is our team of baristas who will serve you. We have a great team. We're really lucky to have 2 assistant state climatologists, Bridget and Ed. Paul Buckman, who's here in the audience, is our postdoc, full-time postdoc. Dia is our science writer and communication specialist. And we have 2 outreach specialists as well, Josh and Amanda. Amanda's here in the audience, also an AOS grad. And then Lyle Anderson, our longtime office manager. We also are fortunate to have 3 student researchers that we're supporting. Z.E. Shu, all of them have AOS links. Z.E. Shu is a recent grad. Noah, who is here in the audience, and Aaron. I don't know if Aaron's in the audience, and they're both working here as AOS students. Next. I'm highlighting Paul and Amanda because the 3 of us will be taking turns. Go back a second.
I'm sorry.
It's okay. We don't want to shortchange them. They're going to be taking turns with me doing these climate briefings over the course of the year. Next. My summary today is going to focus on the month of August and the summer, June, July, August. And the highlights are listed here, and they turned out sounding a bit like Jeopardy categories, but that wasn't the intention. It ain't the heat, it's the humidity. When it rains, it pours, and where there's smoke, there's fire. Next. August was really boring when you look at the entire month average temperature and precipitation. Other ways it wasn't so boring, as I'll get to. But in terms of average temperature for the month of August, this is the departure from normal. And all the gray means plus or minus 1 degree Fahrenheit. That's pretty minor. Where it was a little more cooler than that, it was a degree or 2 around Dane County and elsewhere, but still only about a half a degree cooler than normal statewide, right in the middle of the long term since 1895. Although frankly, any month nowadays that's cooler than normal is almost a headline, and August did fit the bill in that respect. Precipitation also, if you go statewide, nothing exceptional, about 0.2 of an inch drier than normal, but it mattered a lot where you were. If you were in the north, it was quite dry, anywhere from 1 inch to 3 inches below normal, especially in the northwest. The farther south you went, the more precipitation you picked up, and then we'll get to this bullseye over southeast Wisconsin in a moment. Next slide. Now for the summer, it was a lot more interesting. It was a warm and wet summer in Wisconsin. So you see that for temperature, a lot of places here in the light orange were about 1 degree or 2 warmer than normal. And when you averaged it across the state, we were nearly 1 degree Fahrenheit warmer than normal statewide, which I know doesn't sound like a lot, but keep in mind, averaged over a season, and the fact that summer is the season with the least variability, that ends up translating to the 30th warmest on record, and that's in the top quarter. Precipitation, you see a lot of green on here, right? So that means it was a wet summer, anywhere up to 3 degrees in the light green, and some places more than that. And for the entire summer season, about 1 degree or 1.5 inches warmer than normal statewide. 25th warmest or wettest statewide since 1895. Next. Now the real story, I think if you ask most people about this summer, and John alluded to it last week, it was really humid. It was super muggy. And this graphic shows that. These are statewide dew points for the summer. 2025, second place, back to 1979. Only the summer of 1995 had a higher dew point, and that was the one that had the Chicago heat wave, the really deadly Chicago heat wave. Madison, during that heat wave, had a dew point of 81. And by the way, the temperature was 100 at that hour, so it was real comfy that day in 1995.
That was a surface theta E of 358.
There you go. There you go. The other takeaway is look at how many summers lately have been really humid. The dark greens above average, 9 of the last 10 summers have been more humid than this long-term average, and most of them by quite a bit, including this summer. Whether this is the new normal remains to be seen, but this is what we're dealing with, at least over the past decade. So if you've been here a while and it seems like we've had humid summer after humid summer, you are correct. Next. One of the things that a lot of humidity does is that it tempers the daytime heat and it elevates the nighttime heat. And we can see this from this graphic. One of the metrics we monitor in the state climatology office is hot days, 90 degrees or higher. And out of convenience, we often do it just averaging these so-called first-order weather stations around Wisconsin. These are ones that have been around a while, reliable airport records. And from that, we've calculated the number of 90-degree days for every year, going back to 1950. You see a lot of year-to-year variability, but the long-term average here in the red line in 2025 in the dot. So you see that we were actually below normal in terms of our hot days, although we still may squeeze out 1 or 2 yet next week. But the other thing to note is this is a trend line. This isn't just an average, and it is flat as a pancake. And it's really surprising that despite the fact that the climate's warming, summers are warming, and yet we're not seeing it in Wisconsin in terms of hot days. Next. But we are seeing it in terms of really warm nights. The high humidity helps to keep the nighttime temperatures elevated. These are the number of nights 70 degrees or higher, really uncomfortable for sleeping if you don't have AC. And those are getting more common in Wisconsin. You clearly see an upward trend, and you see this red dot indicating we're well above the average, and even well above that trend line. So more nighttime heat, less extreme daytime heat is the trend. Next. Turning to the other end of the humidity spectrum, that being dry, smoky air, we had that too, particularly in late July into early August. It had been so muggy up until that time with a lot of southerly winds. When the wind shifted to the north from the northwest, we started getting all this smoke from Canada. And this is showing the extent and the qualitative measure of the intensity of these wildfires. And I didn't realize they were so widespread. I knew they were in Western Canada, but it's understandable then when the wind started shifting from the northwest, we paid the price for our comfortable air masses by getting that humidity or that smoke into Wisconsin. And here you see some scenes. I think this is downtown Milwaukee. Can't tell where it is. But we had remarkably 9 straight air quality alert days in Wisconsin. We had lots of scenes like this one. And that was a new record. That was even worse than 2 summers ago when we had all the terrible wildfire smoke. We never had more than 4 days at a time. So this was really something for its duration. Next one. And the worst day of all was the first one on July 31st. This is a post Amanda made that got really popular, turned out. 6 Wisconsin cities in the top 10 for worst air quality in the whole country. Milwaukee and Beloit took the gold and silver, but there were other stations around Wisconsin that were also on this list. And just out of curiosity here, notice over 40,000 views. That's the most we've ever gotten in a tweet. And it ended up creating kind of a political row, right, with Canada. A lot of elected officials in Wisconsin latched onto this and pointed their finger at Canada for their poor fire management practices. So we didn't intend to get into the midst of a political battle, but you never know. Next one, Pete. And then the final theme here is flooding. Milwaukee just got hammered in early August with historic rainfall. I've just read over $75 million in damage. That number will probably go up. A perfect storm of synoptic factors. There was really high precipitable water, favorable low-level jet, stalled front, and then mesoscale convective vortex as part of the attribution. Because of that, there were scenes like you see below, American Family Field. The Brewers played the next day somehow or another, but roads were closed en route to the stadium, and the Wisconsin State Fair lost its final day because the fairgrounds look like this right outside. Next. And to put it into perspective, now this is a figure that shows the estimates of precipitation from this event. This is a 2-day precipitation accumulation, but most of it fell within 12 hours. And these blue colors, this shade of blue, is anywhere from 4 to 8 inches. And notice it wasn't just Milwaukee, it was many counties into Lake Michigan. And then the dark blue indicates 8 inches or higher. And this little dot here is over 12 inches. An absolute maximum reported at a school 14.5 inches on the north side of Milwaukee. I'll get to that in a moment. Yeah, it's incredible. Here are the return intervals, the exceedance rates, how often you would expect to see a rainfall of this magnitude. Again, the bluer the color, the more extreme it is, and you see anywhere 100-year event, 200, 500, even 1,000-year rainfall event. So this is incredible. And it wasn't just, a little tiny part of Milwaukee County. This covered a fairly big region. Next. So, question, is this going to be a new statewide record for daily rainfall? 1,000-year event, might be, right? So this is the time, if this were a football game, when the officials would come out and say this call is under further review, and in this case, it's going to be done by an ad hoc committee that NCEI puts together. It's called the National Climate Extremes Committee, and it involves representatives from NCEI, from the National Weather Service, and the State Climatology Office, and maybe 1 or 2 other organizations, and we review what happened. We review that rain gauge, see if it met the right protocol, all sorts of things that go into it, and then at that point, it's established whether this is a new statewide record. So any record for heat, precipitation, whatnot, goes through this review committee. Next. And then the final slide here is to show you just where this event may end up. If it is verified, this 14.5 inches in Milwaukee, see how it compares with Wisconsin's single-day rainfall records. Those are shown in the table. The current record is a mere 11.7 inch drizzle by comparison, compared to 14.5 inches. And then you see these others that are close behind, most of which were actually in this Milwaukee area event around Waukesha. The others being in the big Dane County event in August of 2018. So, anytime you establish a new statewide record, it's remarkable, but this is almost like a record for breaking a record by about 3 inches. So we'll see if that pans out, and maybe Paul or Amanda will update us as the news comes out from this review committee, whether we have a new statewide precip record. So I will stop there if there's time for questions or comments, or else we can take it at the end. Yep, first here.
So all of those other events have one specific day, whereas the Milwaukee event it's over 2 days. Was most of the event on one of those days?
Yeah, this is really a 24-hour reading here. So this is one of the challenges with daily rainfall records. Do you mean calendar day or do you mean 24-hour day? And I don't know, Amanda, did you break it down that way in terms of this when you have this table here? I think this one was a calendar day, but it could all, calendar day is also 24 hours.
I think from what the National Weather Service said, it was calendar days.
Calendar days, okay. Yeah, so typically when we say single day, I think it's usually meant 24 hours, but that'll be also part of the process. So just the fact that I showed 2-day rainfalls in that radar, that almost doesn't mean anything because almost all of it was within a 24-hour, even a 12-hour period.
Okay. Was most of that on August 9th or was it on August 10th?
I think it was on both. I think it straddled midnight, as I recall.
Mostly the 9th.
Mostly the 9th? Okay. Yep. And Michael?
Thanks very much. This is really great. Question I have is back to the humidity and the high dew points that we had. In terms of attribution, are there any sort of possible sources for what's contributing to that? And not to get the
go back to
Wisconsin
that.
Corn Growers Association.
Yeah,
angry
corn
at us.
sweat.
But in terms of the the irrigation of crops
Yeah.
in the upper Midwest, I'm wondering what's that impact?
Yeah, so a lot of times when the bar graph of the dew points, the time series, yeah. So there's been a lot of talk in the media about corn sweat, the evapotranspiration that we get, especially from Iowa, places that are even more corn growing than Wisconsin. It's not clear how big of a factor that is. It certainly doesn't help. And if you look at records of corn production, corn density over time, it's gotten a lot more packed. So, you can grow twice as much corn per acre nowadays than you could 50 years ago. So that's a lot more ET. But when I looked at this, what I saw was in this same climate engine tool, which is actually a really good source if you're interested in getting some of these kind of data points, they also show an option for wind anomalies. And if you look at the V-wind anomaly for July, it's really strong. It's coming up from the Gulf. And other people have written about this summer dew point and shown that it was something that happened over the entire eastern 2/3 of the country, and that it was mainly because the Bermuda High in the Atlantic was shifted farther westward than normal. So it was just pumping up this Gulf air for most of July and then a lot of June. So, we can talk about corn sweat all we want, but if you have that kind of synoptic pattern for that long, it's going to do a lot for boosting your dew point.
Right. But the interesting thing is when you look at sort of maps during that time period, the highest dew points were actually concentrated in the upper Midwest. So even with that transport, there was some, that might have been the extra kick to...
Yeah, that's right. Right, it might have been the kick, and I think that's probably the best way to do it. Corn sweat by itself isn't going to do it if you don't have the other favorable ingredients. John?
Yeah, along the same line, Steve, I think I've got a student who wants to work on this project, inspired by this summer, thinking about theta E at like 18Z or 21Z, every day. I hope Climate Engine can help us out on this. But I think that would be even a better measure than the muggy nights, because the theta E is the thing that really can, people would quickly start to get a sense of, oh, wait a minute, 325 is a little bit at my threshold. Anything higher than that, I'm uncomfortable. I think it would be really interesting to see all of this kind of portrayed that way.
Yeah, maybe we'll... Go ahead.
Incidentally, 1988, the hottest summer we've ever had, was below average in humidity.
Yeah,
Very
isn't that
different
something?
year.
Yep. Yeah,
It's
and
a
then...
dry heat.
Yeah, exactly. And then 1992 was post-Pinatubo volcano, and it was mainly because it was such a cool summer, one of the coolest summers on record. This was 2009 was the coolest July on record. So some of these low values are just because it was cool. The high values could be it was warm or it was humid. I don't remember 2010 being especially warm, but it was certainly humid. But 95 was just literally killer warmth. That was memorable summer everywhere. Okay, anything else? Yeah, Michael?
Sorry, this is just fantastic. For the smoke, you were talking about the shift in winds, but we've been largely, since late August through just about last week, cooler than normal. I expect that we'd have some flow from Canada, whether it's north, northwesterly, even northeasterly. With all that smoke, what's happened up in Canada that's changed the source regions? Has it gotten just wetter up there in the last bit? Have they got the fires out or what?
Tariffs, that's what it's been. Put a tariff on smoke, so it took care of it. That's a good question. I've wondered the same thing. So with the cool weather we've had in early September, we haven't paid the price with wildfire smoke, which is a little unusual. There's one day when I smelled it a bit, but nothing like it was in August. So I don't know if the fires have I'm sure they haven't completely dissipated, but maybe the worst of them are over, or maybe they've shifted to another part of the country. I haven't followed that source region as much. But anyway, Canada, this is the second worst wildfire season in Canada, I read. Only 2023 was worse. So we've had two real bad ones in 3 years. Anything else? Okay, thanks for your attention. I'll be around later if you have any questions or comments at the end. Thanks.
Thanks. Thanks so much, Steve, and the whole office. That's fantastic. We're going to enjoy this.
Can you hear me okay? Okay. Thanks, Pete. I think we'll start with the little semblance of climate that I have to show you today, which is, where's the HDMI? Oh, yeah. Thanks. And we're into September 1st. Now it's the 12th, and so I'm keeping track of the 850 millibar cold pool. And I've got the data up to yesterday. So here's our annual trace so far this year, and here are several different averages over the last several decades, and then the maximum aerial extent and the minimal aerial extent for each day. So this looks kind of bad, right? That we're really lower than average by a mile, and it's an unusually warm first week and a half of September. This is only the 17th warmest, September 1 through 11. 5 of those 17 occurred outside of the 21st century. Every other one of the 12 were in the 21st century. So, the dice are a little bit loaded, and there's just another example of that, even in an 11-day swath. So we'll see. Regionally, of course, and you'll see in the forecast, we're going to enter another second little burst of summertime. We're into it already. It should last several days. I don't know if that'll be hemispherically shared to continue this trend. But I wanted to show you that. I'll try and do that every couple of weeks. But not very comfortable. I don't like having a jacket and a tie on when the dew point's over 60. So if you find that I'm grumpy, I'll apologize now. You're damn right I'm grumpy. All right, I want to say a couple of different things here. First, I want to take a look at our current satellite, not the long one. We'll go to that later. We'll take a look at the current satellite over the continental United States. The weather is not particularly interesting right now in a lot of places over our fabulous country. As you can see, most of the weather is offshore, both on the cloudiness and its precipitation elements undoubtedly embedded within those regions of cloudiness off the East Coast. Look at the entire eastern third of the country is just about perfectly clear, a little bit of daytime cumulus developing over the Carolina coastal plain, same in Georgia. And then a little bit more menacing-looking cloudiness. I think there's a little burst of convection here in central Minnesota coming across the border into our own state. We'll see that in the radar in a minute. That might be about the only strongly convective element over the whole continental 48. There may be something over the high terrain, probably that spotty daytime heating stuff that we've seen all week long. I don't know how dry the air is underneath. We were talking about this in 452 yesterday, how dry the air might be underneath some of those cumulus clouds at high elevation. But that's the kind of stuff that can start wildfires. A lightning strike in an air mass that's so dry that the precipitation associated with the very thunderstorm that produces the lightning strike, that precipitation never hits the ground. I'm not sure if that's occurring today in Colorado, Wyoming, New Mexico, Utah, the whole Rocky Mountain states. So, and then the other thing I want to talk about today is and I'll do it only briefly, a storm that occurred earlier this week along the Aleutian Islands. It's really got some interesting characteristics, and I'll just give you a couple of highlights of them. as far as I understand them at the time. And then the other feature of interest is the beginning of the development here off of Maritime Canada. Southern part of the Labrador Sea. In January, several of us will be sitting here in an Army barracks waiting for January and February, waiting for these kind of things to develop, so it'll be kind of fun to be there. For me, it'll be great. I mean, average high is like -5 at Goose Bay in January. It's perfect for me. I'll be the only happy person on the base, I'm pretty sure about that. But anyway, I'm going to enjoy that. So let's go now to the radar, Pete, to see what fraction of this cloudiness, if any, today is actually precipitating, and then we'll take a look at some maps. So not surprisingly, it looked a little bit more convective up over Minnesota, although this piece here over the border with South Dakota and Minnesota is a bit surprising. I don't think I would have noticed that one. This one's the one that I kind of had my eye on from the visible satellite image. But a whole line of really spotty, sometimes pretty intensely convective storms. I've got some purple in there, 65 dBz in this event right here north of Minneapolis. So that's a pretty decent convective line, but it seems isolated in the sense that there's not too much else in the region. A few showers have made their way into western Iowa. And then here, again, it does look like they're kind of convective showers that are spotty and jumping off the high terrain of the Colorado Rockies. I don't know if there's better organization than that. Perhaps a peek at the upper level charts will help us to see that. And as usual, it's almost true almost every day of the year. It seems like there's going to be a few showers somewhere in the Florida Peninsula, but particularly under quiescent conditions as we have now. So that's nice. You can tell that New England's got a beautiful day. Much of the central United States is also quite nice. Only a few spots where it's precipitating at the moment.
I think this stuff near Washington and western Pennsylvania is bugs.
Oh, is that right?
I think there's a
Insects.
lantern bug.
Wow,
Like,
interesting.
bloom right now, and the radars are picking them up.
Yeah, you know, and I don't think that tariffs are the thing, Steve, about the smoke. I think we have an excellent leader who's dealt forever in smoke and mirrors. So there must have been a trade of mirrors for their smoke. So I think that might be what's going on there.
Let's reflect on those.
Yeah, and we can reflect on that at leisure. Let's take a look at a surface map, the continental one. And the reason is I want to look at the dew points. So we're talking about mugginess, and I think this is really interesting. Unfortunately, we're headed back, it looks like, into a period where it'll be relatively muggy. So 73 over 57, you know, that's not so bad. I was surprised at how dry the air felt this morning when I walked out to work. I thought I was going to be already angry about the weather, and I was wrong. It was pretty nice. So it's struggling, the dew point's struggling to get to that threshold that I don't like to see, 60 degrees. It's probably going to do it today. But even down in St. Louis, it's 87 over 60. That's almost a crisp early fall day for St. Louis. However, we'll see when we look at the sea level pressure the reason why. And the unanalyzed sea level pressure is a little harder to see. Maybe you can see a general circulation that's clockwise around here. And at our longitude, we're sort of right in the middle between northerly flow to our east and southerly flow to our west. And when the anticyclone is going to only slowly sag to the south and east, and quite slowly, which will account for how long-lived our sultry conditions when they arrive will be. But we'll get onto the western side of that feature, and then you'll get into sort of this Kansas-type dew points of 85 over 64. At Kansas City itself, the dew point is 63. Down in the southeastern part of the state, the dew points are nearing 70. And then into Texas and Oklahoma, you're speckled with 70 dew points, but all of them in the high 60s. So that's on the way, I think. And there's no real way to get around that. But it will take its time, and then the problem on the other side of the taking its time will be it'll stay here a while. It's like a visit from your in-laws, you don't like it too much. Sorry, maybe you all have fine relationships with your in-laws. I do too. Upper level charts now. No, I do. My wife does it. Okay. Let's go to 300 millibars first. And at 300 millibars, first of all, kind of a decimated map. We don't have observations at all the stations we're used to. But I think it's easy to tell almost immediately that most of the high wind speed jet activity is well to our north. So here's one piece of it out over the Gulf of Alaska. Then a little bit of mitigation in the middle part of northern part of Canada. And then again, a feature along the Canadian coast and then going south of Greenland towards Europe. Nothing over the continental 48 states in terms of strong wind speed. So this light shading here in gray, I think is 70 knots max. Yeah, so we've got a few in Salt Lake City, 75 knots. The same down in southern Nevada, that's 80. and an 85 in Southern California. So that's as strong as the jet gets at 300 millibars. Good day for air travel. Everybody's going to be on time and probably relatively quick on the long distance flights. But a really saggy flow at 300 millibars. Not much to move disturbances along at this level. Let's see what it, meanwhile, in the jet belt, you could call it, there's a couple of disturbances of interest. There's one over the Maritimes, which we'll say something about. There's one over Hudson Bay, and then there's a broader scale trough over the Gulf of Alaska. That's all at 50-ish degrees north latitude. Let's see what it looks like at 500 millibars. And not surprisingly, the same general picture. I think it's a little easier without the isotachs to see the three disturbances. Particularly, one can pay attention to their thermal structure. They're not that cold. We had temperatures at 500, I think, maybe within the last 10 days that were colder than minus 24. So that's minus 24 in that one. It's minus 18 on the eastern shore of Hudson Bay at 500 millibars. What is this, early July? And then along the whole west coast of Canada, you got to go all the way up to almost the border with Alaska to find minus 24 again. So it's not that cold, but it is a little bit wavy. And these waves, of course, spawn cyclones. But all of that activity, which you could associate with fall and the cooling down of the hemisphere, is at very high latitude. So what I am interested in at this time of year is the phasing between what's going on in the cosmic background. The sun's going to go down at the North Pole in about 10 days and not come back up for 6 months. And then it's going to the darkness will slowly invade from the north. If that coincides in a really nice fashion with the beginnings of the threat of snow at high latitude in Canada, particularly Western Canada, that can set the stage for some early season cold spells. And then those themselves can drag that snow line further south, and it's what Nabias called the snow blitz. And you can kind of initiate something about the coming season if things work in tandem in quite the right way. So a month from now, if I continue to see waves across central or maybe southern Canada by then, I'm encouraged that maybe we're going to get ourselves off to a good start for the winter. And as Michael and I say, bring it on. We're excited about it. Waves over the continental United States, every single one of them has a positive tilt. That trough, that ridge, that trough. And the jets to the north. And it turns out that such positively oriented troughs and ridges flux momentum poleward. And so what's happening, in a way, is that you already have the jet to the north. All of the waves to the south tend to reinforce that in their current configuration. So I don't see any abrupt change back to what we enjoyed in the first week of September, because the jet's going to stubbornly stay northward as the waves to its south kind of encourage that stubbornness. So that's kind of an interesting thing. Off the maritime coast of Canada, so here's Newfoundland. And so there's a pretty sharp upper trough. There's going to be a disturbance that develops right here to the east. But it's not going to be very long-lived, because look at this confluence zone south of Greenland. It's going to be like a meat grinder for whatever gets developed here. It's just not going to be able to produce a ridge downstream. It doesn't look like in the forecast. So that feature will be relatively short-lived. But that might be the way they go in the early part of the cold season, which we're in now, especially at that latitude. They can't generate enough of their own circulation, latent heat distribution, all that, to really reconfigure the flow at high latitudes. I think that potency gets a little bit more impressive as you move further into the cold season. So we'll see about that. Let's see. Can we take a look, Pete, at our own, the charts that you make for 500 and 300 millibars at 12Z? Yeah, so 500 at 0Z. I meant at 12Z, but from 0-hour forecast. So looking now at the 500 millibar map colored with respect to vorticity, it's easy to see at least two of the main trough features. The one over Hudson Bay is an isotropic vortex maxima, and this one over eastern maritime Canada, maybe a little bit more ellipsoidal, but pretty strong, much stronger. It's in the order of like 4 times the Coriolis parameter there, and here is about maybe 3. And then nothing at all of any substantial magnitude over the continental United States. But this feature immediately down sheer of it off of the coast of Newfoundland, that's probably the spot where one might expect the most substantial vertical motion. Can we take a look at my QG Omega and see how that looks? I didn't bring that up, so sorry, I forgot about doing that. And we'll do the 0-hour forecast right here is a good one. This will be the same time. So there's our couplet of vertical motion, at least as diagnosed by the quasi-geostrophic omega equation. This is at 700 millibars, so one imagines it's probably roughly the same to 500, a little bit weaker perhaps at the ground. But there's Newfoundland, and so down shear of it, the dotted lines are 500 to 900 millibar thickness, so they kind of give you an idea where the thermal wind is. In the vicinity of that upper vortex, there's a pretty strong thermal wind, tight gradient of the thermal, thickness lines, and down shear of the vorticity maxima, which is right over the island, that's where the ascent is. The descent is stronger, and so this is an asymmetric couplet. The cyclogenesis will go on here, so anticyclogenesis to the west. And then the Hudson Bay feature, though it's a potent vortex structure, has almost no thermal shear associated with it. You can see that in the thickness field. Consequently, pretty weak vertical motions. Not too much development to be expected out of that. And son of a gun, if some of that precipitation in Minnesota isn't somehow tied to a broad scale support, at least from the large scale circulation. That's pretty nice. Okay, one more thing I'd like to show you, and that involves Viz 5D. Well, first, let's go to Alicia Bentley's page, which I think is right here. These maps are really nice. Can we go to the Pacific, please? And then let's go back to, we can just go back. I think these are the archived ones. Go back all the way to 0Z on the 7th of, not a different, yeah, I guess that's how it's done. 0Z on the 7th is right there. Okay, great. And then can we get, I don't like this picture, we'll get sea level pressure and, yeah, this one's good with the jet. Okay, thank you, Pete. So this little cyclone, if we go back even further, in fact, let's click back a couple of times. Look at what happens. This is on the southern part of Japan. That looks like a tropical disturbance, doesn't it? Really intense sea level pressure minimum. And then if we go forward a little bit, Pete, now we're going back towards 0Z on the 7th, which is this time right here. That's the remnant of that tropical disturbance, but there's something that's been conjured a little bit further to the north, which also has a really odd thermal structure. It's kind of a thermal ridge right in the middle of the cyclone, so one gets the impression that maybe it also has initially some tropical characteristics. Then let's just march forward and watch what happens to that disturbance. Really strong thermal contrast. The red lines are 1,500 thickness, so there's a really strong thermal contrast. Of course, the tropical cyclone dies away. The extratropical cyclone, in its vigor, continues, and here it goes toward the Aleutians. I'm sorry, did that suggest a bias? Really strong baroclinic zone. It's down to about 982 millibars at this time. And then it kind of fades away. Watch this. So not rapidly, but it's not really intensifying any longer. So it's a short-lived but fairly intense development right along the central or western part of the Aleutian chain that maybe had some sort of a tropical origin. And that's not uncommon at this time of year.
Can we keep going forward on this?
Oh, yeah, sure.
Just watching the, what's now hitting British Columbia, I think it was the remnants of that initial TC remnant.
Oh, yeah, you're probably right, yeah. So let's take a look now at Viz 5D. I want to give Michael time for the forecast. We can take the cross-section off. I just wanted to prove that it took all the stuff that I've saved, and then you'll have to slide up because we've got some weird variables here. And take W off. We're looking at sea level pressure. Everywhere where it's 1,000 millibars or lower is light blue, and then everywhere higher at 4 millibar increments is yellow. And this is 0Z on the 7th. And there's the GFS 1 degree by 1 degree representation of the perhaps tropical disturbance. Here's the northern islands of Japan, and there is the new disturbance. Let's put theta E on top of this, Pete, at I think it's at approximately 950 millibars. I know it's rather ugly, but we're going to watch this. So let's march forward in time. So it doesn't really have much thermal structure. Now it's starting to take on something. This is when the tropical feature starts to die away. We can keep going. That starts to look pretty interesting. Not quite yet even. Go a few more times. Yeah, right about here. It looks pretty interesting. So here's the center of the cyclone. Really sharp cold front. Does connect back to maybe some vortex structure from the tropical disturbance. And then a nice warm frontal structure and a beautiful thermal ridge. Let's take a look at a cross-section of theta E. I think it's at, yeah, that's at the right time. So now if we tilt up, there's your warm frontal structure all the way to probably up to like 300 millibars. Here's something like a cold frontal structure, and then there's the occluded theta E axis that tilts upward, westward, and poleward. And so it's poorly stratified. I also put vertical motion on that. Let's see what that looks like. Wow, that's pretty intense. It's only upward vertical motion. So really intense vertical motions coincide with that structure. So that's a very nice example of how the occluded structure looks, and also that it gets to be very often filled with really intense vertical motions. Let's go back to the top view if we could, Pete. And we'll get rid of the theta E in the horizontal, get rid of the cross sections as well. And then let's put potential vorticity, the 2 PVU surface, right here in the isosurface, thanks. The 2 PVU surface, and we'll go back a few times in the animation. Should have put the sealable pressure on top, so maybe we can. Can we slide the 1,000 millibar or higher? Yeah, so that's the center of the storm we're looking at, and it's tied to an upper disturbance in the tropopause. So you can see the slope of the tropopause. The PV equals 2 surfaces colored by pressure, so these yellows and greens are at higher pressure and the blues are at lower pressure. So let's go forward a couple of times. And it's great to have Pete doing this because he, on the fly, makes good choices about the colors. So here comes our storm. And look at this. Right here is a good time to stop. Sort of a new depression, a deeper yellow in the tropopause right there. So one imagines, perhaps, that there's this really intense development going on both at upper levels and at the surface, and maybe it's kind of like a standard development, PVA by the thermal wind and all that. Undoubtedly, that's contributing. Let's tilt this up. Wait till you see this. Was ist das? So we've got this tower of PV colored by pressure. So this is just not more intense PV. It's 2 PVU still, but at low pressures. Now, seeing that, one has to go back in time and see, what did it look like at the beginning of this evolution? Did this just start all of a sudden? And we're back to the beginning in 1 or more 2 clicks right there. No, it did not just begin all of a sudden. There was always something there. That's the remnants of what might have been this tropical feature off Japan. And then if we tilt back up to the top, there is this upper trough feature here, but there's something else here, which is underneath that is where this PV tower is. So there is development that goes on aloft, but it phases with this tropical remnant. And let's kind of give a half tilt, Pete. Is that what you wanted? I want to see that too. And then we'll kind of go through this moving forward so we can kind of see that might be too much. Let's slide back to like right down this front down. Yeah, so you can see the cyclone develop. And let's just step through that.
Sorry, before you do
Yeah,
that, or
yeah.
before you- so the piece of, I have to get up because I don't know how to describe. Is this piece closer in or is it further north?
Oh, this one right
No,
here?
The other one.
This one.
No. That one. Yeah.
Oh, I don't know where that is. We can slide it around.
So
It's further south. It's
So
further
that's
south.
the sort of an upper part of a post-TC tower.
Oh, I don't know. I never thought of that. I never thought of that when I was looking at this.
Yeah.
Possible. But then how do they get disjunction? Because that one sits maybe more on top of this feature. Is that what you're thinking?
Right, but
Yeah,
remember
yeah.
the red one, the lower one.
Yeah.
That's where that tower emerged from. Unfortunately, we can't go further back. Something along the warm front north of the cyclone.
Yeah, you can go further back, not with this data set, but you can go and look, and that would be really interesting to see. But let's watch this evolve from this perspective. And so the cyclone always maintains this really intense PV tower, and it grows. Why does it grow? Let's put trajectories on. And I've got a couple plotted. I think number 3 is one of them. Yeah, so here they come. Let's get out of trajectory mode, or we're going to have problems. And then click forward. There goes the air straight up through the core. If you take the PV off, you'll see that. See, there's the updraft. So this thing is getting stronger and stronger as a PV tower by the influence of this really extreme vertical motion that suddenly comes on. And that vertical motion, if we go to the top PV, put the PV surface back on, and then maybe we make it transparent. All these things you can do with Viz 5D, unbelievable. And on the fly, you do them on the fly. I think it's the right mouse button. Does it?
That's gonna change.
Yeah, don't do that. You know, when you come up, you can get individual colors or the color scheme, right? I think I know. But
Is that like a control or something?
let's see. Let's close this. What is it?
It might be like a control or shift or something.
I can't remember. Anyway, we don't need to do it. It's going to take too much time. I forget 2P. But you can make it transparent. The thing that I wanted you to see is you'll see that air parcel's going straight up right in this region under the influence of this upper wave. So now let's just keep moving forward. Wait till you see what happens next, and then we're done. What's that? That means that you're seeing all the way down to the surface through the 2PVU universe. And if you tilt it back up, they're 100% connected now. And this coincides exactly with the time of maximum intensity of the storm. And after this, the storm starts to decay slowly because this whole structure gets disjointed. It never really comes together for reasons that I didn't have time this morning, and I certainly couldn't speculate intelligently right now. But I think you have the tools available to maybe figure that out. So anyway, pretty interesting storm. It didn't look like much, and I meant to go back to the satellite. It had a nice satellite presentation, but it didn't have the time to do that. But there's a lot in there. So anyway, sorry I took a little too much time.
That's good. Thanks, John. So to get started, let's first go to Pivotal, please, and go to Forecast. Kind of just look broadly out. We'll look at the CPC outlooks first of all. So this is the 6 to 10 day outlook put out by the Climate Prediction Center, and it shows the likelihood of above normal temperatures across the entire United States, with perhaps the exception of the Outer Banks of North Carolina. But for our weather, it looks decidedly like we're going to be above normal temperature-wise for the next 6 to 10 days. And if we go forward to 8 to 14, the probabilities of being above normal come down a bit, but still looks like the die is loaded a little bit for us to be above normal, at least for the next 2 weeks. But above normal could mean a degree, it could mean 5 or 10 degrees Fahrenheit. So we'll see it as we look at the forecast and how it evolves. How about precipitation? For the first 6 to 10 day period, slight chance of being above normal precipitation-wise. And then as we go forward, we see things begin to maybe dry out a little bit, where it's sort of equal chances of above or below normal precipitation. It's like the southeastern part of the United States is going to be rather dry as we enter into the middle to last part of the month. Okay, so before we get into weeks ahead weather-wise, let's look at sort of close in on the current weather. And we'll go to kai.aos.wisc.edu, please.
Is that a new website?
No, same website, just some slight modifications. Still working.
I'm sorry,
That's something else. Okay, we saw this last week. Still updating some things, and I appreciate Pete's help in terms of converting some of these loops to HTML5 loops, so I have to do some more myself. Let's scroll down to the bottom and go first to John's favorite meteorogram, forecast meteorogram. And first of all, I want people not to panic. I know John would be thrilled if this were true. First of all, here's the temperature. So at least in the world of the model, we at least have 60 hours ahead. The world will exist for the next 60 hours. That's one way to read this. But the key thing is the trend in temperatures slowly beginning to warm up, maybe tomorrow being slightly cooler for reasons we'll see in just a moment, then warming up. Dew point-wise, minus 62 to minus 58 for a range. But no, there's something wrong with how this is getting decoded at the output from the model.
Are you sure?
I'll work on that. I'm pretty certain it's not going to be that dry. If it were that dry, I'll buy everyone a lunch next week. Okay. And then finally for precipitation, this is kind of interesting. This big burst of precipitation. So the red is the 3-hourly precipitation rate, and then the green is sort of the total accumulated precipitation over the entire run. And we're looking at a precipitation event starting just before 12Z tomorrow morning and ending probably by 15Z. And then that's the big burst of precip, which is first of all going to perhaps If this precipitation occurs, ground is going to be wet, all the incoming solar radiation, if we get much sun, is then going to be used in evaporating that rainfall as opposed to trying to dry, to heat the soil up and then mixing, contributing to a warming process over us. So looks like in the forecast, at least in the short term for this weekend, some rain very early tomorrow morning into the maybe mid-morning, and then things shut off. Let's look at the time height section next, please, Pete. So again, this is from WRF model run, initialized using the NAM this morning, 12Z. Yellow contours here are isoplex. These are isentropes of potential temperature. So this is the isentropes. Red is vertical motion, and red is relative humidity, contour above 70% and above contoured, and then blue is vertical motion in meters per second for this domain. So we get this really big burst of convection over us late tonight, early tomorrow morning. What we can see here initially are a couple of interesting things. First of all, with these isentropes, as the vertical motion begins to sort of pump up, that's what the blue contours are showing, we do get these isentropes beginning to get elevated. This is just before the precip comes in. So there's cooling because the air is unsaturated, or it's nearing saturation, but it's rising so rapidly. We're getting cooling occurring. These isentropes bow upwards, so columns getting cooler. Then as we get condensation occurring, we get a sort of a balance between the condensation, so the release of latent heat, and the adiabatic ascent. And so things kind of level off temperature-wise after that period and kind of stay level over time. If we look closely near the surface in this layer, again, we can see our well-mixed layer from this afternoon into this evening, and it continues into past midnight. Really strong surface winds with a varying with height, so that's indicating warm advection in the lower troposphere. Okay, and so we can see the slope of these isentropes close to the surface getting lower and lower, and that's perhaps a warm front beginning to approach our area. Precipitation comes in, okay, with these really strong vertical motions between, let's say, 9Z and 15Z tomorrow, and then after that, things sort of clear out. We see that the near surface layer, relative humidity, say 70–80%, so there could be some clouds, but I wouldn't say it's going to be a washout or a totally cloudy weekend coming up. But after that, Sunday and Saturday into Sunday, looks like, again, relatively quiet. Other interesting aspect of this map, we see some green here because of the high stratification. The green is potential vorticity above 1.5 PVU, but when we normally see, as we get into winter, we'll see the tropopause, dynamical tropopause, show up on this map pretty prominently. But as John's indicated, the flow pattern right now is such that the jet is well to the north, so we're not really going to see much of that in this particular diagram. All right, and winds near the surface southerly for a good part of the through tomorrow morning, and then become more easterly after that. All right, so let's now look at we'll quickly step through the forecast. Let's start at 6 hours in the forecast. So this is the accumulated forecast over the 6 hours ending at this particular time. We see that the model is capturing, at least from the initialization, over north central and northeastern Minnesota, that convective area that showed up there. Interestingly, there was, I think, a line of convection that extended into western Minnesota that's just not picked up by this particular run. Just noting that, to be honest about it. And if we go forward in time, let's go to 18 hours in the forecast. Okay, some of that precip begins to head to the east and to the southeast, or has begun heading east and southeast. And you can see our thicknesses haven't changed too much. There is a cyclone out over South Dakota, southern South Dakota, but it'll stay out to the west during this period. Let's go to tomorrow at 12Z. This is when some of the rainfall is over us. You can see this is picking up a track of a area of precipitation across the northern part of our state into the peninsula. If we scroll down a little bit, we can see hopefully we'll see the legend here. So those brown colors are in excess of an inch of precipitation in that 6 hour period. So the northern part of our states can get a bit wet. And here's, at least through 12Z, some of the rainfall that we have over us. So again, as John was saying, if you look across the country, eastern part of the country, not much really happening except, again, just offshore in southern Florida, precipitation. Currently, most of the precipitation action is right over us, and then over the western part of the United States, there was some over the mountains, and that's kind of pretty much the same pattern, except that we're getting another burst of convection, or not another, but a burst of convection over Montana and the Dakotas overnight into tomorrow morning. Okay, let's go ahead to 18Z tomorrow, so 30 hours in the forecast. Okay, that precip, this is accumulated precip from 12Z to 18Z. So we'll see when we look a little bit closer in that this has begun to move off. But you can see the thermal ridge that's out to the west of us kind of stays there. These isotropes aren't moving rapidly toward the north, and perhaps they're being slowed down, at least locally, because of the cold pool beneath this convective pattern. Watch the time. Okay, go ahead a little bit more to, let's go to 42 hours tomorrow night. Okay, so that precip area continues migrating to the southeast. And for us, again, sort of dry conditions tomorrow evening. And we'll go one more click to 54 hours into the forecast. And again, that sort of fades out. But again, the weather patterns that we see here with the cyclone that's been kind of lingering over the western part of South Dakota, the Dakotas, just stays there. So we're kind of locked in with a ridge over the eastern part of the United States into eastern Canada. That heat isn't really making a big run at us. It's getting close, but not truly close. If we go back, Pete, to 850 millibars, the large maps, we'll go to 12 hours in the forecast for this evening. You can see that warm advection pattern that's over us. Sort of the nose of it is where we're seeing some of the precipitation beginning to break out. These winds are a little bit stronger than the ones just out ahead of it, so a little bit of localized warm advection to the north. We saw in the time height sections also warm advection in the lower troposphere as well. But if we were to, next week we'll be able to animate these. Let's go ahead to tomorrow morning, 24 hours at 8:50. Okay, again, really warm temperatures. This first red is about 22 degrees Celsius, which if we were to mix down, that would get us into the low to middle 80s if it were to reach us, but it's still kind of hung back just to our west. We're going to be getting into, this is tomorrow morning. Let's go to tomorrow evening. Sorry. Go ahead to, 36 hours. Well, it just gets to south of us. So if I were to look at the temperatures explicitly and assume that we were able to mix all the way down, that's at least 12 degrees we'd be adding to this temperature that's at, on this red color. I want to make sure I'm getting this right. 20, 12, 22, 12. Well, that would be an extreme. We're not going to mix that deeply. That would get us into the middle or upper 80s, but I don't think we stand a chance of that. Quick thing, just want to show a couple other items on these maps, and we'll have more time to describe this next week. We also have local maps. This is on a 27-kilometer grid. This is on a 9-kilometer grid. And if we go to, say, 12 hours in the forecast, you can sort of begin to see this shows temperatures and surface winds. These are 2-meter temperature, 10-meter winds. And if we go ahead to 24 hours tomorrow, when that rain is supposed to be coming in, again, you can see that track of really heavy precipitation over us, and then over Dane County. Here's Madison right here, getting close to, it's a few tenths of an inch of precipitation at this point, and we get more after 12Z tomorrow as this comes through. Let's go to 18 or 21Z tomorrow. So let's go here. Okay. What's interesting here is with that convection having ended, the ground's been cooled off by the precipitation. Again, it's over for us. You can see the isotherms as they get stuck here. We are right along the edge of a warm front. Right, strong southwesterly winds here. Temperatures getting to 36 degrees Celsius just for southwest over parts of southeastern Iowa, whereas here we're in the, about 26, 27 degrees Celsius. So there may be just enough clouds or the ground being wet enough to help keep things from really warming up, getting super warm. But that heat is going to be to our southeast. If we go ahead to Sunday, and this will be the last time we'll go to 54 hours, 57. Okay, and looks like we do get into the middle 80s, or this is 30s, 86, so we're going to be low to middle 80s, and again, really warm just to our southeast. Extended forecast into next week really has us rather quiet temperature-wise, And actually precipitation, we don't get a lot of precipitation through the next 6 days or so. Looking at, forecast beyond a week from now, looks like we begin to cool off again. So that'll be kind of refreshing when we see that. But higher dew points, precipitation on the way. If you look at the Weather Service forecast, as dew points getting into the mid-60s by the time we get into Sunday and Monday, unfortunately. So that's it. If you want to get cool, go to the lakes. Get over the lakes where they stay cool.
Get in there.
Anyway, that's it. First of all, thanks to the State Climatologist's Office for a really great presentation. Looking forward to more of those. John, Pete, thank you very much, and the attention of the folks here in the audience. Have a wonderful weekend.
Yeah, thanks, Michael. That looks nice.
No, it's old school, but I may, I don't know if the time invested trying to get.
It's worth it as opposed to